Good afternoon, everyone. Unfortunately, I don't have my camera connected to this system, but it's all right because my first slide, when I now share the screen, you see what I look like. So I think we'll manage with that. I thought that maybe I can tell you something about this synoptic situation at the moment, and also maybe a bit about the forecast during the weekend, because there might be something very nasty coming, especially to Finland, and I will talk to you about that. And also in the second part, where you call, I think, some like science section or whatever you call it, I also have a few slides prepared for that. And yeah, I'm using only slides this time. And actually, it's not my first weather briefing I'm holding. I'm there in EUMeTrain. Actually, it's my second. The first one was in 2019, so it's been a while. But, so let's get going. First of all, I did this also the last time. So, where are you participating from? And I will assign you all to annotate, so then maybe you can check or mark that where you are currently from and what you are doing. So are you a forecaster, researcher, manager, trainer, or something other? Okay, so at least we have a lot of forecasters, and then we also have other people here. That's right. Very good. And all across the Europe. Great. All right. So thank you very much for this. I will now go to the second slide. So when we are now going through this synoptic situation at the moment, I actually checked the meteor alarm to see what kind of situation is it going on in Europe, and there is actually a lot of things. So, for example, in Germany, I actually saw something yesterday also from Esteffects. There might have been some mesocyclone activity or something like that, and still there are like red winds, and of course we are not forgetting this heat wave in the southern Europe either, and also some forest fire risk also in the Scandinavian area. Apparently it has been quite dry in Norway, and also it has been quite dry in Finland, but then something happened and it's not dry anymore. So yeah, there is a lot of going on, and maybe the next image is the Airmass image. So I know that we all love satellite images, and especially when it comes to EUMeTrain. So here is the Airmass image. It's from 9UTC, and it's from the ePort system from EUMeTrain webpage. And it also tells very nicely about the system or the situation in the Europe. So we have this very warm tropical air mass here, and then we have something dry air masses maybe indicating something. I have a slide there next, and then also we see this system in the northern part of Europe, or actually in the Atlantic Ocean. So that's the remnants of the system that was bringing us a lot of precipitation to Finland last weekend. And that's about the science section today. So this actually, it's 9UTC, so something has already happened. So I think you can already see these like small thunderstorm cells forming here, but I think you can see it more nicely from the microphysical image. But now, the next image is water vapor. So this is also from 9UTC, and I love these little exercises, so I will assign you all to annotate once again. So can you try to find the jet streams? Just based on the image. Yes, nice job. It wasn't too hard. Actually, it's very clear from this image. Yes, this is now ice tags also added to this water vapor image, so you can see it very clearly. 50 meters per second, here is the jet streak. And also something going on in here as well, because we saw this system from the previous image. So the next would be HRV clouds. So this is something that, by the way, we use a lot in Finland. And since we are so far up in north, we just love when we are having this sunlight coming after winter, so we can actually see something from visible channels as well. So we love this. And once again, low-level clouds. Can you just mark an area where you can find some low-level clouds? Yes, yes, very good. So if you remember how these HRV clouds is being written or being read, I mean, you can just know that it's in yellow or yellowish color depending on the time of the year and also the sun elevation angle. And yes, definitely so. Then the opposite, so the bluish or whitish colors, they are the thick clouds there. So then I have one last task for you. So thick thick ice clouds with small ice crystals on top. So can you mark maybe a few of those, or just, thunderstorms is just one example. Any small ice crystals on top is just fine. Yes. Nice job. Okay, this was also quite clear. I think maybe colors on your screen might vary a bit, but I will show you this. So color interpretation, this is from the RGB guide directly. So actually, personally, I was just following these thunderstorms and how they are developing since it's relatively close to Finland and I'm also on shift at the moment. So I have to do the nowcasting. And also, of course, we don't forget that these frontal cloud bands also tend to have these small ice particles on top of the cloud. And yes, I think you can see very easily also the water clouds. I think it's this color here, so it's like pinkish. So I think there are also a lot of like low-level clouds and water clouds, also like around the Europe at the moment. Okay, so this is the situation now at the moment, and I noticed that not too many weeks ago or many months ago when you had a briefing about ingredients on convective weather. I checked it out, and I think it's just very, very nice here to go through once again, because what we are having in the between Sunday and Monday in Finland might be something that will be remembered for a long time. So something also about the forecast from Finnish perspective. There is a misspelled. There should be from. So I'm using ECMW model, and let's look from Saturday until Monday. And these are quite easy to follow. So first of all, so we have a system rising from the south during the weekend. So these black thick lines are ice lines, so pressure lines. And then we have precipitation in greenish color, and then wind barbs. Yeah. And also these gray areas are cloud cover. So this is now 5th of August, so it's on Saturday, and there is something low pressure system here which is forming, and then it's traveling north. So if we go to Sunday, this is Sunday, so it's hitting, this is warm front here, it's hitting already Finnish borders, so from south, so we might get some elevated convection there. And it's getting deeper. This low pressure system is getting deeper. And then the horror story begins on Monday, so August 7th. And so it's at the worst, according to the forecasts at the moment, and actually 3 days already like past to the past as well. So it has been like this for 3 days. And it's not getting any better at all. So I know that if you are forecasters, like many of you were, there is this ingredient-based methodology. So each ingredient is forecasted separately. So where the ingredients meet, we get the system or thunderstorm system. Not necessarily lightning, but we get the system there. And the ingredients, there are 3 of them, so lapse rate, moisture, and lift. Then sure can be considered as one, as it's very important in organization of the system. So I have some figures, so some images from today's 00 UTC ECMWF, and the forecast is valid on Monday, 7th of August at 12 UTC. And I have to say that it's I'm considering Finland now, because it seems on every forecast that we're like getting it at its worst. So, all right. So I have marked here. I will explain it while I'm going through. So here are the first ingredients. So lapse rate on the left top corner. So it's between 850 and 500 hectopascals, and it's between 6 and 5 kelvins per kilometer. So it's actually quite favorable. I like the rule of thumb is when it's over 5.5, we can have the lapse rate is unstable enough to produce convection. Then the air mass temperature is 20 degrees Celsius. I know many of you were from Southern Europe and you have experienced something that maybe never before, but in Finland, 20 degrees air mass temperature, so 850 hectopascal temperature, is something that happens maybe a few times in 10 years. So it's extraordinary and very, very exceptional to have these warm air masses so far here in North. So usually we get like maybe 10 or 12, and if we get more than 15, we would be like, oh my God. So we also have the point here is actually not the temperature itself, but the lift. So this was the warm front, and this is the warm sector, and then there is the cold front, and cold front works as the source for lift. Then on top right corner we have mixing ratio, so it's telling us about the moisture, and it's from 40 to 15 grams per kilogram. Once again, exceptionally large in our latitudes. Our forecasting expert just said that it's gonna be very, very, very moist, and these high moistures we don't experience maybe even in not once in 10 years or anything. So it's gonna be, well, it's favorable for convection, obviously. And then we have effective bulk shear. I'm not sure if you can see the numbers, but I can tell you that they are between 25 to 32 meters per second. So it's like deep mean layer shear, but it's effective, so it's taking the cloud height also into account. And just based on these numbers, it already looks very, very, very bad. And then we also I have some more information. So this is the last slide about this system. So mixed layer CAPE. So CAPE is moisture and lapse rate combined. So we have energy about 1,000 to 2,000 joules per kilogram. Well, I don't know, it might sound not that bad, but once again, in our latitudes, it's very rare to get even near to 2,000 joules per kilogram. So it's actually quite bad. And then on top right corner, we have SIN, so convective inhibition and forecasted precipitation. But actually, unfortunately, ECMWF is not that good in this convection weather forecasting, because it's not able to It's not able to bring a solution for convection. So yeah, it's not actually showing anything. And then on top right corner, top low corner, we have precipitable water here. So like what would be the moisture content in the air pillar. So it's from 40 to 45 millimeters. So in case of very slow moving thunderstorm cells, we might get some flash flooding. This final index on bottom left corner is something that we call CSI. That has nothing to do with the TV series, but it's still named after convective severity index. So it's developed here at the FMI, and it takes all the ingredients into account, and the color corresponds to the warning limits that we use at the FMI. So I have never seen it this red or even purple. I didn't even know that there is a purple color before I checked this case a few days ago. And it means that according to our standards, there might be damage that is within the limits of our red warnings. And of course, we don't have any purple warnings, but if we had purple warnings, they would be a disaster. So I didn't put in any wrap-up slide here, but what would I expect here is something that maybe could produce many downbursts like Derecho or quite fast-moving MCS with a lot of downbursts, maybe tornadoes, large hail, with supercell thunderstorms, tons of lightning. The top of the cloud temperature were -60 or something. So it's gonna be very interesting case to see what actually happens. So I'm waiting for Estofex to also react this. I didn't see anything on their page. I would have taken a screenshot in this presentation. But yeah, it's happening on Monday, so there are some factors that are not, well, it's not sure that it's happening like this, but if it is, it's gonna be a small catastrophe from our standards. But do the second part now. So the science part, and this is just statistics this time. So let's head back to July. Yes. So July was actually not that rainy. It was kind of maybe normal, but due to last weekend, we got some very heavy rain. So locally, even record-breaking rainfall. And one may say that it was raining cats and dogs. And the synoptic situation there was a low pressure system over Scandinavia and Finland. So we got some moist and warm air with frontal system that was arriving from southeast. And I have an image here. So this is an analysis chart that we make daily in Finland. So this is from 28th. So it was Friday. So 12 UTC. And there was the system. So it was arriving from southeast, this system here. There was some old occluded front, so might have contributed this also a bit. And the air behind this front was very moist, but nothing compared to what we are having this weekend. But still, it was very moist. So what happened was that the frontal system became stationary. It became stationary over Finland as the occluded front continues to swirl. I also have an image on that. So this is a forecast. You can't see it because it's on the very top, but it's a forecast made 12 hours before the actual situation. And this situation here is valid on Saturday, 12 UTC. So yeah, and then this occluded front just keeps swirling inside, and it just stays there in the middle of Finland for the whole 2 days, so 48 hours. And the precipitation amounts that we got actually were quite huge. So on the left, we have 24-hour precipitation accumulation on Friday. And then on the right, we have 24-hour precipitation accumulation on Saturday. And I'm missing number 2 there. There should be 29 point, so 29th of July. And then this is also radar imagery from Friday. And these are the actual values. So 58 millimeters in 24 hours on Friday, and then 48 or 50 millimeters on Saturday. And when we combine these, we get over 24 hours, we get a lot. So over 100 millimeters of precipitation, which is 1/7 of annual precipitation that we got around those areas, and just in 2 days. And actually, the record-breaking precipitation fall was in Multiala, so it was like right there where the arrow is pointing. In 24 hours, 103 millimeters, and it made it to the list of top 30 largest rainfalls in a day. And but it was like on that particular station, it was a record. And just to mention the heavy rain scale, so why it feels so exceptional from our perspective is that we are warning even when it's raining more than 50 millimeters per 24 hours or 20 millimeters in 24 hours. So it depends. It depends a lot how we get the warning. Oh yeah, 20 millimeters in 1 hour. Yeah, so that was just probably hit the both limits there. So we had the warning there, so no damage, and we knew this situation coming beforehand. And about damage, there was actually surprisingly little damage. So in east of Finland, we had some power outages due to gusty winds and lightning, and the gusty winds also, well, they were also because of the low pressure system, not so much because of the thunderstorms, because there were not that many in there. Of course, some fallen trees, some flooding locally, and then actually behind the system there were 1 or 2 tornadoes associated with thunderstorms. And the precipitation was continuous, so it wasn't flash flooding. So I think that might be the major reason for that. It didn't actually do that much of damage. And there is the graph of power outages in Finland. So we got the most of power outages on Saturday, where we got the most of the precipitation as well. But not that many actually. It can be tens of thousands when we are actually hitting a system like thunderstorms or MCSs or systems like that. Okay, so that was my last slide. So thank you for your attention, and I hope you enjoyed or get something out of it.